Okay, Professor Bhupendra Goswami, it's a pleasure and a privilege to have you with us today. Just to introduce you very briefly, he grew up in Patpausi, an interior village of Assam, and is one of the most distinguished and well-known climate scientists of our country today. He did his pre-university in 1966 and BSc from Cotton College in 69, that's in Guwahati in Assam, and Masters in Physics from Guwahati University in 71. He then went on to do his PhD in plasma physics from PRL, Ahmedabad in 1976. And soon after his PhD, Professor Goswami started working on weather and climate processes at PRL. PRL is a physical research laboratory. In 1978, Professor Goswami got an opportunity to do a 2-year postdoctoral work with Professor Jules Charney, who is also known as the father of modern meteorology at MIT Cambridge, USA. And this was followed by 3 years at the NASA GSFC, which is the Goddard Space Flight Center, USA, working on the upcoming field of monsoon modeling. Returning to work in India in 83, he worked at the Indian Institute of Science in Bangalore from 85 to 2006, becoming professor and chair of the Center for Atmospheric and Ocean Science. During this period, he made several fundamental contributions in understanding variability and predictability of the Indian monsoon on interseasonal and multi-decadal timescales. Then he took over the helm of the Indian Institute of Tropical Meteorology in Pune in 2006 as its director, and he really transformed the institute to doing world-class research into a world-class research organization. Leading the Indian Monsoon Mission program, he bridged about a 30-year gap and brought Indian weather and climate prediction capability to be at par with some of the best in the world. The improved skill of weather and climate forecast in the country today is a direct result of his vision, strongly supported by the Ministry of Earth Sciences in computing infrastructure development and capacity building in weather and climate model developments during 2006 to 2014. He served on many national and international committees, including the Joint Scientific Research of the World Climate Research Program. He has been visiting faculty at the Princeton University and Maryland University, both in the US. And today he's a professor at the Cotton University in Guwahati, Assam. He has won numerous awards. It's a long list, starting with the Shanti Sir Bhatnagar Award, and he's a member of all the Indian National Academies and the Third World Academy of Sciences. Published extensively some of the most best-cited papers from the country on climate science are by him. So it's a real privilege for us to have you with us this evening and share your perspectives on research and development. And I'm sure we'll see it from the perspective of a leading climate scientist. And thank you very much, Professor Goswami, for making the time. And we look forward to listening to you.
Thank you so much, Dhruva, for those kind words. And thank you for inviting me to talk on this occasion. I'm a bit nervous because I am comfortable in giving a technical talk, but this is more of a philosophical talk. So I am a bit nervous about it. So basically what I'm going to do is give my perspective. So the document indicates that I think we should discuss about these 3 different sub-schemes on research and development in science and technology in higher education system. One sub-scheme is on introduction to the constituents of research. The other is on strengthening the research and its contributions. And the third is, of course, an assessment. I feel that talking about all these 3 aspects will be difficult in one, and we may not be able to go in detail about any of these. So I decided that, and I also believe that many of you, the senior faculty, already know the constituents of the research and how the assessments are done and so on. So I think most important thing, I believe, is strengthening the research and its contributions in our country, especially the university system. So that is why I decided that I'll focus my talk mainly on this aspect, not the other 2. And this I will do by basically setting the background on which we should talk about the improvement or the strengthening of the research and development. So I'll talk about why we should have research and development in the context of what do we mean by research and development in the context of NEP, and then I'll talk about a little bit about need on research and development in science and technology innovation in the higher education system. And then, of course, we have to have an idea of what is the status of research and development today and how we can improve upon this. So these 3 points are basically the background on which I will talk about finally how we can improve this situation and how the university system can contribute to accelerating the science and technology innovation in the country. So basically, this is my main theme. But to do that, you have to set the background, and I'll talk about that. But before going into the talk, I need to, I must say that I have been fortunate to learn about various aspects of research and development in working under different institutions and different environments. For example, in my training in physical research laboratory and later on postdoc at MIT and NASA gave me the helped me to learn about research ethics and research culture. In Indian Institute of Science, I learned about the value of the basic research and the value of the academic environment. Yeah, IISc has an excellent academic environment that excited us to do the work that we could do, we wanted to do, and of course. From IISc to IITM, when I went, that was an application of basic research. So IITM is an organization where research is taken to applications, and that was their basic philosophy. And so there I learned how basic research can actually help improve applications, and that is where we have my experience in basic research in monsoon science, and the processes helped to improve the weather and climate models. So that is one of the things that I realized, and of course, lastly, I have been working in the Cotton University for the last 6 years, and this gave me a perspective on the state of affairs in state universities, and so therefore, my talk is based on my experiences working in these various environments, and so this is basically a personal perspective on how we can improve the research and development in the universities, and therefore And I come from weather and climate science, and I'm basically a theoretical and modeling person. Therefore, I will have my own biases. So I may not be talking too much directly into the experimental research, but the examples that I might give are sort of generic that might have similar applications in the other areas of research. So therefore, I will proceed with saying that there will be a little bit of bias, and the examples that I give from my own experience, own research, will also be sort of trying to. It might look like that I'm trying to promote my research, but that is basically, I think that there are examples to be learned from my experience in those examples. And this talk is basically my aim is not to educate the senior scientists, but I think my experience might help the young scientists to motivate to do excellent research. So what is the in my understanding is that the research and development is required in the higher education systems, because to transform the institutions from of the higher education from just degree giving institutions to institutions of real learning, and empowering the students to really solve problems actually, and to get jobs. To get jobs, they have to really solve real problems, and therefore I think and the research and development, the methodology and the culture and the ethics that we learned is what is important for empowering the students to train for solving these kind of the important problems. To achieve this, we have to excite the students, and they have to be passionate about the subject. Otherwise, this excellence in research and development is unlikely to happen, because unless the student is really excited. And so to make the make the students excited about the subject, and just not thinking about the degree, but actually learning about the subjects and thinking deeper into the system. And that requires research and development is an important part of that. Because I believe that education inspired by only cutting edge research can really empower the students to learn and empower them to solve problems of all kinds. And how can we do that? I think this is a philosophy that I think some of the institutions are now following, like ISER, I think had started. I was associated with ISER Pune for a few years, and I was very happy that they are actually the students are engaged with cutting edge research into laboratories which are already doing cutting edge research. The institutions must have those in the first place, and then get the students engaged even from the undergraduate level into this excitement that is going on in these labs. And therefore, once you do that, the students will really get excited about this, and that really makes a big difference by the end of the time they finish BS/MS, they are well prepared to start research, and they are already start making very important contributions in the PhDs. And so I think this model of education which is inspired by cutting edge research should be our theme in the NAP, in the implementation of the NAP. And so, why do you need this the R&D in the higher education system? So why do you need R&D? Because R&D has actually is research and development over the last 2 centuries. We know that we have supported the population from over the last 2 centuries has grown from 1 billion to 8 billion. And the life expectancy has increased from 25 years in around 25 years all over the world in 1800 to about, many places it is 70, 80 years, even though there are some places where it is relatively low, but still the progress is tremendous. And this has happened because of the science and technology innovations over the last two centuries. And those innovations have actually made the science fiction of the yesteryears to become reality within my lifetime. In fact, I have a couple of examples as I always get excited about it. So one of this movie I have seen when I was undergraduate is called 2001 Space Odyssey by Arthur Clarke. And that at that time, this was a real science fiction. That was just the spaceship had a computer, and the computer developed its own mind and started controlling the spaceship. And of course, all that mayhem took place. So that time it was really science fiction. But today it is not science fiction at all. It's reality. You already know that all these artificial intelligence development in the last few years has shown us that, like AI bots like the ChatGPT is already having its own mind, and we have all these challenges that we are talking about, whether they will really take over decision making by human and go and create all kinds of sort of problems. And so that science fiction has become reality within a period of about 60 years. And in fact, going forward, this kind of science and technology innovation might actually change us. The science and technology has become so much part of our day-to-day life that actually we are changing ourselves. In fact, I have just read a recent book by Dan Brown. It's another science fiction book where his protagonist, which is an innovator, who has a model which sort of established what is the origin of humankind, and then how the human is going to change in the coming decades and years. And that is his prediction is that the human race is going to change completely, actually stop existing and become a completely different race, which is a combination of all these technology and human. So we are going to transform ourselves to a different humans. I think this is happening. It's almost happening slowly, I think. So things like these are happening. So the science and technology has been a very important part of the evolution of humankind in the last couple of 100 years, and it's going to actually transform us in various different ways. But this science and technology revolution has also created a problem for us. This is the problem because of the industrial revolution and the way we have used the natural resources like the fossil fuels has created essentially the climate change problem, which has essentially led us to an existential crisis. So the whole that industrial revolution, which actually made possible for human to increase all these, sort of prosperity, gain prosperity and increase longevity and so on and so forth, but also created this problem. And this problem itself it appears that it is going to become a existential crisis. And in fact, people are talking about the sixth mass extinction, maybe because slowly a lot of species are dying, but even human might have a existential crisis. So, so therefore, as a result of this, and we are facing a lot of challenges in the food security and water security, for example, because the increasing population is having a smaller area to produce more, because and that is becoming a big problem, big challenge. On the other hand, the rainfall, the freshwater source is not increasing very much. It is increasing at the rate of only about 3% as per degree increase of global mean temperature. But the population has increased so much. The per capita requirement is decreased considerably, and the climate change is creating a lot of variability, large variability and disasters. As a result, the food security is a very big challenge, going to be a bigger challenge coming forward. So all these challenges require solutions. Now, where does this solution come from? It has to come from science and technology innovations, but with a focused effort, because instead of building more and more defense equipments, I think we have to focus on more and more how to solve these problems. So this is kind of a focused innovation is required, and that is a very big, very big challenge. How do you achieve that? Now, there are a lot of challenges in achieving this. In fact, there's geopolitical reasons which prevent us from progressing the way we'd like to do. For example, you know that the whole question of the global warming, we know that we need to limit it at a certain level. 1.5 degrees is considered compared to the pre-industrial level is what is the point where If it goes beyond that, the whole climate maybe go over a tipping point, and it will never be able to come backwards. No matter what you do, even after that, if you start cutting emissions, it will not help. And do whatever you do, you may not be able to come back. There is a feedback, positive feedback will start, so that it will go over, and then maybe the global mean temperature will increase all the way up to maybe 8 or 10 degrees above, like 65 million years ago. So to restrict that, to avoid that, we need to have drastic cut in emissions, but that's not happening. But everybody agrees that it has, in Paris Agreement, everybody agrees that this is required. But no country, most of the countries have not done that. As they go back and they don't do that. In fact, not only they don't do it, many of them are for geopolitical reasons, they are not only not cutting emissions, but encouraging them. Encouraging fossil fuel use. For example, this is data on how different countries are undercutting fossil fuels cost. That means they are giving subsidies. So, so United States spends, for example, $600 billion every year in subsidizing these. I think this is outrageous. And where you talk about the climate fund and $1 billion of climate fund, it is not coming from anywhere, but they are subsidizing so much for. I think this is the kind of dichotomy that we have, and this is the problem, and this in challenge that we have. And under this challenge, we have to we have to make this innovation. Now, how do we do that? It requires a lot of investment, but that investment is not coming forward. For example, the innovations in green energy creation over the last few years are decreasing over globally. So this is a curve of how the green energy innovations had increased up to about 12 globally, up to about 2012. But after that, it is decreasing. That means people have been diverting their money in the other areas. So these are challenges. So and this climate change is going to have a disproportionately large impact over India. And the country needs to increase the science and technology innovations and mitigation and adaptation by maybe almost 10 times to deal with it. But this 10-time number is just an arbitrary, just off my head. But we need to significantly increase this. But the government and the private sector must invest also much more on focused R&D to cope with the adverse impact of the climate change. But government labs alone cannot do this, right? Because the number of people, expert manpower in these government labs, all the top universities are, or the government supported centers of excellence or whatever, that those institutions like ISC and few others, and there are about 100 such institutions in the country, but that manpower is very small. And that is not going to make a quantum jump in this, cannot make a quantum jump in these innovations. So this is where the university system comes in, the role of the university systems. I believe that the university system must make a much larger contribution into the R&D sector, the science and technology innovations. And that is a very important requirement. Why I'm saying that? Currently, the university sector, except for these government, funded some of the top institutions in the country, the overall university system is not. The rest of the state universities and the private universities are not making any significant contribution into this. Now, as far as the status in the country, as far as the science and technology status in the country, let us talk about the number of publications, because the bedrock for all the innovations in the innovation is basic research, and the basic research in science and technology can be gauged by quality publications in the science and technology. And so this, I can use that as a guidance for the kind of status that we have today in comparison with other countries. For example, in fact, the country has made some significant progress in the last few years in improving the total number of publications in science and technology. So this is the total publications globally, and this is America's, United States. China has become #1 today, and it has overpassed the USA in total number of publications, and they publish about 3.5 lakh or 4 lakhs, I think, publications. America publishes about 3 lakhs. They publish about 4 lakh papers, and India is about 1.5 lakh papers. So, but India has overcome in UK and Germany in the last few years. So India is making progress, but the quality, even though the number is increasing, which is still not as much as we would like to, but while we have overcome the UK and Germany in terms of numbers, the impact-making publications, number of the impact-making publications still remains relatively small compared to USA, EU, or China. For example, suppose we can have an index of how to gauge that. The share of top 1% cited journal articles of the that is produced by the country may be an index of how we are doing. And if we normalize that with all the other countries, then you can see how we are doing comparatively. So suppose you have 100,000 articles published per year, a country, and out of that 1,200 of these are in the top 1% cited articles, then their index will be 1.2. China's index is 1.2, while India's such index is 0.9, whereas China and USA is 1.9, almost 2. So still the quality publication we are lacking, and we need to improve that. But that, I must say that it's a caveat. I must say that none of these are an absolute, but on absolute in a sort of index or absolute parameter that evaluates that gives us a. But it gives a kind of broader idea idea for comparison. So now, now where does this come from? Basically, most of the research come from our PhD programs and the postdocs, right? And then most of the basic research in the leading institutions, whether it is university or the government research, that comes from the PhD programs. And our faculty members, we do work, but we work through our PhD programs. It is the PhD program that actually so the PhD program must improve in our country, and so if you see how that comes from all these different institutions in the university. I took this report from the government of India, Ministry of Education's recent report, and these are our universities. For example, there are like 400 odd state universities, and about 365 private universities. These institutions of national eminence are all those IISc, IITs, etc., all those. So these are and some of the research labs. So these are the institutions which publish, sort of do most of the, the bulk of the research. So, and the deemed private university is 80 and central university is 51. So together with central university and state universities, we have almost about 800 universities. Okay, and compared to the other institutions are about 150, let us say. So this is something that we need to give this number. Let me, how do we say, what is the contribution of these universities, or especially the state universities, to the impact making publications in the country, or impact making research in the country? And to do that, first, let us just go through how many PhDs we produce as compared to the USA, for example. So apparently we produce about 24,000 doctoral degrees per year in the recent times, compared to about 60,000 PhD in total in both humanities and science and technology. And science and engineering, they produce about 40,000, 45,000 PhDs every year. Whereas we, from the ICA report, I found that we produce about 11,000 PhD. So our number is small, but it is more than number. Our quality also has a big problem. The problem is not just the number, it is the quality of the PhDs, and that is a big problem. So as I argued, that the quality and quantity of the doctorates produced in the country determines the health of the research ecosystem. However, it may be noted that number of students enrolled in the doctoral programs at credible institutions where students need to carry out credible research is relatively low. And that number is maybe 20% of that. In other words, that only about 20% of maybe 2,000 students, PhDs are most of the 2,000 PhDs are contributing to majority of the research output that we are having. So that is a problem, and we need to change that. Therefore, India doesn't just need the numbers. We need the numbers, but the number is not enough. But we need to rather increase the quality of the PhDs. So just to give you an example, why I say that is because let us look at this contribution of the universities, and especially the private and state universities, to some of the national level awards. For example, INSA awards. INSA fellowship is a coveted sort of award. It recognizes excellence and contribution by scientists. And so there are about 1,000 INSA scientists, INSA fellows. Out of that 1,000 INSA fellows, you have about 120 comes from the universities. And out of this 120, about 79 comes from the central universities, and only about 28 comes from state universities and 13 from the private university. And that is like 2.3%, 2.8% from state universities, and 1.3% from the private universities. So
Pardon?
Yes.
I wonder if there is none in this INSA fellowship from degree colleges ever.
That degree colleges I have not seen.
Yes.
No, not at all. I think I may be wrong, but I think I had looked at it because I had to figure out this distribution myself, and then I looked at. I did not find, unfortunately. Yeah. So this is that as I'm saying that this may not be the only way to look at this, but it gives an indication that we are not the state universities are not making enough quality publications, or enough students, enough faculty who is producing students of that quality, which is making those publications. So I think this is our major problem. So my focus will be how we can improve that. So this is if we can improve this significantly, we'll be able to actually really overcome this in the USA. But even otherwise, I must say that with a smaller number of people and the smaller contribution, we are still making a big impact. So those people who are actually making, they are working harder, they are producing better papers. And so we have a great potential, but we are not fully utilizing it. And why we are doing that, we have to figure out. So in my opinion, how could so what is actually to understand why the private universities are not able, or the state universities are not able to make this contribution? We have to understand what is the problems, that what is ailing them, what is ailing that system. And in my opinion, there are three factors that ailing the system. One is the faculty recruitment, and the other is the poor science and technology infrastructure. And third is the academic environment, the environment for academic excellence and the research culture. So I will talk about this the last part in some detail, but I will not get into this. But these two are not mutually exclusive, because unless you have a good faculty recruitment process and you get good faculty, meritorious faculty into the system, into the universities, you cannot really produce better research. And that is the key thing. And the university system is the recruitment is highly, there is no autonomy of the institutions. There is political interference, and so therefore the recruitments are done not on merit, but on something else. So therefore that is a very serious problem. We need to improve it. The other thing is the poor science and technology infrastructure. Most of the state universities, I think almost, I know for sure because I have been in one of these universities, and government just does not give any money for infrastructure. And unless they give, how can you even start building something? And then to get also better funding from others, you have to produce some good research. And if you produce good research, to produce some initial good research, government has to start giving some startup fund and infrastructure. And that is missing. And as a result, you cannot just start the process. So these are two different important problems. But most importantly, these universities, this academic environment for academic excellence and the research culture is missing. And that is something that I'll talk about a little bit more.
Professor Goswami.
Yes.
I have a query.
Yes.
I mean, in your experience, what will be a good faculty member to recruit with, and what will be the ideal recruitment process?
Yeah.
Because my experience says that I appeared at some places and the interview and everything, I mean, the entire process went only for 10 minutes. So I find it very, very insufficient to judge anybody in 10 minutes.
Absolutely. No, I agree. All that is the problem here. As I said, today in many of these the faculty, the weightage to the.
Sorry to interrupt you again.
No problem. No problem. I think no problem. I think I would appreciate you can interrupt, because I have planned for only about 45 minutes. So I think even with interruption, I will not exceed time.
That's good. Right.
So
most of the time, faculty members, they have not, the recruitment, the people on the recruitment panel, they have not gone through the CVs. They have not gone through the research plan we have submitted. They have not gone through the teaching philosophy we have submitted. And then they ask all sort of questions, which are not channelized. They're random questions, one from here, one from there.
Absolutely. Those are details actually. And I that's why I flagged this as the major problem. This is the first number one problem. But to make, I mean, philosophically, I'm not going into even though that requires working out the sort of, it has to be, first it has to be, autonomy has to be given to the institution, the sort of VC of this, to establish a powerful sort of nationally competent committee for selection, right? And that is one thing that many times it doesn't happen, and even if it happens, it is sort of so bypassed. So those are issues that actually question of details. But our objective should be in the institutions. Many times, there's many of the state governments in my own state. I am following that. Not they look for local persons. They give preference to the local persons, but not on merit. So my problem is that we should aim for getting the best person available in that particular field, that particular thing, best available in the country, not anywhere, whether it is in Assam or Bengal or Tamil Nadu. It should be the best person that should come to the institution, and that the most meritorious person. If we give that as the criterion for selection and leave it to the expert committees and allow, then obviously we'll get the better person, and it can be done. It is question of that political will of how it is done. For example, in Assam itself, the IIT was formed 25 years ago, and the director of that or the first director was visionary, and he actually established why IIT is doing today well, because of that vision that the first recruitments were the top class recruitments, and because they set the research agenda, they set the research culture. So next appointment will be with that only. So therefore, any institution, the first recruitment should be top class. And if once that is done, then those people are going to recruit other people into those departments, and they will also follow the same kind of culture. And that is what is required. But it's not happening in this state universities, and that is something that we need to. So I'm not going to talk too much on this. Because that is more of a sort of logistic political issues, and also the infrastructure. I'll make a few comments at the end about these 2 points. But let me talk more on the environment research excellence. So what we need to achieve research excellence, and what kind of culture we need to follow. So what is the vibrant environment, research environment? I mentioned that IISc, I was very happy, very, very fortunate. It was a good environment. So what is that environment? In my opinion, this environment should be such that it excites the students and attracts the students to science, and to be passionate about and passionate about pursuing, knowing the unknown. What is science innovations is essentially knowing, learning what is unknown, and that we have to have that excitement. And we may call if that we can do, probably this we can call that a vibrant research. Unfortunately, in most of the state universities, that's not there. Yeah. My personal experience is that we can do the following things can help. One is like excite by example. So you have to encourage your student and yourself to publish in a high impact factor for journal, Science and Research. Suppose one of the students publish in a very high impact, and then the others will start get encouraged to do that, and that is the kind of you have to lead by example. So some of the faculty, if you start leading by example, then the others will also have to follow, and will follow. The culture will develop, and that is what we need to start. And the students also will get excited. Then of course there are also minor issues, but I think all these things help, like flexible working time. In many places I have seen that we are sort of 9 to 5 culture, and then the labs are closed after 5. That research student, for the research students, I think there should not be any boundaries like that. Let them work on, then they will produce much better, and that is something that I have seen is really helps. Other thing is that the environment, the physical environment and the environment in the institution should be good for informal discussions among students and faculty. And so I found that some informal discussion over tea in IASC used to trigger our ideas. When I was at PRL, we used to have informal discussions among students after dinner. We'll have I spend a lot of time in the libraries after dinner, or we'll lie down on the lawn and discuss about something this and that, and some of the research problems will pop up among students, and those discussions actually trigger new ideas. And this kind of facility is sort of it's a typical chai pe charcha is also an important thing. If you can have good facilities where you can just talk, have a cup of tea, chit chat, and discuss, are things like these are important part of an environment. And the other important part is academic is regular faculty seminars, student seminars, and exciting developments in science and technology. And these are something very important. And most important thing I find is this, that we should have important visitors coming into the departments, into the centers or the university as a whole. Nationally and internationally distinguished scientists, bring them up for a visit for a week or so, and then give lectures and interact with them. And this interaction with nationally and internationally distinguished scientists really excites the students, and that actually not only helps them to get a better postdoc, because their work is then when they discuss with these people, their work gets known to the others around the world, and then the whole thing in sort of has a positive feedback. So that is something that I feel that we should encourage in this. Now, but who do we have? That is what we need. But what do we have? So currently, actually, we are very casual about this. In these universities, I find that most of the students in the PhD programs in these not in those top institutions, but in most of these universities setup I am talking about, I find that they use PhD as a degree, just a degree for getting a sort of college job or something, because and as a result, what happens is that if the PhD, if it's not considered as a platform for doing independent research and making research as a career, if PhD is not considered as a degree only, just to get a job. But job is also important, but unless this degree is good quality, you will not get a job. So, but you will not a good job. So, but as a result, what happens is 90% of these PhD students probably just cannot do any independent research afterwards. So therefore, they cannot really get a good job. So that is a waste. Waste of 5 or 6 years of sort of this thing. I think this is something that we need to change. Because if they want to get a job, if they, without spending 5 years, if they had sort of after masters, if they equip themselves with some other sort of skill, they will get a better job. So why spend 6 years in PhD and not get a good job at all? So I think this is something that we need to think seriously going forward. So we need to change the PhD. A PhD should not be just a degree. It is a training to become an independent researcher and take research as a career, R&D as a career, whether it is in the academics or in the private sector. So if that and if we can change that is how I think we can improve the quality. So, but most of the times, large fraction of our fraternity in the universities are happy to do something trivial and publish a few papers anywhere, whether it is impact factor or not. That is, and then complete the PhD, and that is, I think, detrimental for our. But many of the times I find that argument is also that our papers don't get published because we do work on regional relevance, because that cannot be published in high impact international journals. I think that is not correct, because if you do good science, and there is good science to be done with regionally important problems, but they have global relevance, you have to bring that out. And unless you can bring that out, and that requires a little bit of research, and that if there is a problem. For example, biodiversity in Assam is an important problem, but biodiversity everywhere is a problem. So, and for example, Professor Madhav Gadgil has done all his life biodiversity in Western Ghat, and that internationally he has published all papers, and internationally has become famous because he could link what is the fundamental science behind the biodiversity is universal. It is not local. So similarly, the local problems have universal connection, and we have to identify that and then find out the global relevance, and then definitely it will get published. We just don't do that hard work, and that is what is what. And actually, that has been my experience, and that is something that we need to change. So that seems to be related to our lack of desire for excellence. So I think this is also something that I don't know if we can change, but we have to try to change. But how do we change? How can we change that? We have to have, if we have in sort of high aspirational goals. So we should. What I feel is that we should put ourselves our high aspirational goals. Like we aim for INSA fellowship, aim for Bhatnagar Prize, Infosys Prize, or Fellow of the Royal Society. Aim high, and only then we will achieve something. So I think we need to put our aspirational goal higher. First goal is in practically speaking, first goal should be publish in some high impact journals, impact factor journals. Of course, high impact factor journals is not doesn't mean that they will all the publications in most of the high impact factors are not high impact making publication. So we need to actually make high impact making publications. Most of the impact but this is the only way to go forward. So high impact factor journals, most of the high citations come from about maybe top 5% of the articles, but rest of them then really don't. But still, if you try for that, and that is when we can get high impact making publications. So our goal, second goal, should be to make not only just high impact factor publications, but high impact making publications. Now I'll talk about a little bit about how this later on. I'll talk about how these impact making publications are related to citations.
Professor Goswami,
yes,
sorry, I have comment again.
Yes.
So the goals you have mentioned, I mean, yeah. Everybody must inspire to become one of them. But if you look at the data, the Bhatnagar Prize, most of the Bhatnagar awardees are basically the researchers from the research institutes. Even from the IITs, there are only very few. Same with the Infosys Prize. These are the recipients from institutes like IISc, TIFR. But for people like us who are from like state university, colleges, I mean, these goals are very far-fetched. So do you want to comment on that?
No, I agree. None of these are perfect. None of the systems are perfect. But you need to have some goals. Now, I'm just giving them as an example. But even I know that none of these are perfect systems. But what I'm saying is that we need to, if not sort of. Something like Fellow of the Royal Society or something, you have some big goals, and if not fellowship, at least publish in have high citation publications. So that is a goal that we can have, whether it is because there is a relationship between impact making and impact making publications and citations. The citations which are highly cited, let us say more than 1,000 cited, they definitely have made a big impact. Some impact they have made, and that is what we need, and that leads to innovation.
And one more thing I want to say here, that these all prestigious awards are for doing great research. There are no very good equivalent awards for doing good teaching. So somehow we are ignoring teaching, or because we know this fact. I heard from JKB, Jayant Kumar Bhattacharya, that good teaching leads to good research, and good research leads to good teaching.
Right.
So
I think these
we are not giving any.
Two things are not exclusive, because the good teaching is very important for good research, because I think some of the best researchers are also best teachers, actually. I think, in fact, I know some institutions, the best teachers are actually good researchers. So they must get, they are not really independent of each other, but only there must be a separate encouragement for undergraduate teaching, for example. That must be a different thing. But when you go to postgraduate and research teaching, research and teaching becomes interconnected so much that you cannot separate the recognition from teaching and research. So maybe for undergraduate teaching, there separate encouragement is required, because some of the foundations are built by the undergraduate teachers. And in fact, my foundation was built by some of those undergraduate teachers, and I still remember them. And they were, in fact, one of them was excellent researcher at that time in my undergraduate college. So it is no. All of these have pitfalls. I'm not saying there is not, but unless we have a aspiration, you are not going to achieve it. And that is what, and how do we judge that? So it has to come from publications, and that publication has to have a quality, and that quality can be judged. One way of judging is citations. But small citations also you can manipulate, you can argue. But if you have 1,000 citations, then you are not going to manipulate 1,000 citations. Okay, so that means me that you have made some contribution which people are reading and got influenced by it, and they're citing it again and again. So that is something that even if you don't talk about INSA fellowship, of course I know that many of these Bhatnagar fellowship has now been downgraded, and all these things are happening in the country. There are a lot of other things that we can talk about, but let me concentrate on how we can actually self-motivate ourselves. So that is my. I don't want to talk about the politics, or whatever that is. There are sort of pitfalls in the system at this point of time. That requires a different discussion. So, so it's a second goal should be, or instead of just making. So first you try to publish in a high impact factor journal, but in addition to that, publish. Second goal should be. So that it should make an impact making publication. So how do we talk about that impact making publication? But anytime another thing that I notice in the private in the sort of these universities, the state universities, that many students come to do PhD because many faculty do not have support, and the institution do not give fellowship as regularly. So, like I think the state universities also must come up with fellowships, because they should give fellowship to PhD students. They expect that the fellowship should come from others, and many of the faculty will not have the support or the projects, and therefore they will take students which are come just for working without payment. But those students are not motivated. They cannot do good research. They will not spend enough time. So we need motivated students. Only select good students to come into the PhD product, and support them with fellowship. Without fellowship, don't encourage students to do. They will waste their 5-6 years, and then you will not get a good quality PhD, and it is wastage of time. So, and it's actually detrimental for the student itself. So we should not encourage that. So I think these are things that we need to change. So if we make a goal to achieve this kind of a goal, sort of, and support it with some infrastructure, and we can achieve this kind of a sort of higher goal of impact making publication, for example. So let me give you an example from my own experience. This is a publication history of IITM, Indian Institute of Tropical Meteorology, from 1971 to till today. Okay, and I was there during this period, 2006 to 2014. Just prior to my period, and what is plotted here, the bar diagram says total number of publications. Okay, and the red curve represents the number of publications with impact factor. Okay, so look at this. Just the decade before I went. Joined the institution, publishing about 60, 70 publications. So about 50% of the publications had no impact factor. That means nobody read those papers. Therefore, the visibility of the institution was very poor. There are 124 faculty in that institutions, and they published only about 10 of them were able to do independent research. And that is because of that recruitment policy. That recruitment policy was wrong in the old days. They did not really look for researchers. And so that is a big problem. And therefore, that culture was also developed. So then I changed that. I tried to change that. And what I said is that, okay, we'll consider only the impact factor publications for the review. So, but I did not just stop there. I supported it because the infrastructure and the manpower also was poor at that time. So I improved the infrastructure. We produced high infrastructure. We brought in our scientific infrastructure, including supercomputers, and I recruited 55 or about 60 new young scientists, all with PhDs during this period, and that really transformed the way the institute published. So from by the time I left, the impact factor people were capable of doing their research was relevant, but they're not putting the extra work that was required, like looking at the robustness of the study, the relevance compared to some other bigger problems, connection with bigger problems and other those things. So therefore, they just found some results and published it somewhere. But to make that publication better, you have to look at the robustness, the reproducibility, the other things, and so. And to that requires a little bit of harder work, and that is not there is no incentive for doing that. So I gave incentive, and I supported it by the infrastructure and these things, and that really transformed. And those recruitments that I made, early recruitment, now are actually, after I left, it started declining a little bit, but it has picked up again because those youngsters have become matured and they are publishing much more now, because they had the potential for being independent researchers. So we have to recruit people which are the potential to help with independent researchers and give them the little boost that is required to make good publications. So, now let me talk a little bit about going from just making impact factor publications, like very impact factor sort of high impact making publication. Sometimes we call them a disruptive. Today, this is a word that some people are floating around, so what are these publications, like very high impact making publications? These are publications that sometimes you change the old concept, and sort of old concept gives away to a new concept, and leading the field to evolve in a new direction. And that's that kind of a publication is often referred as a disruptive publication. So I'll give one example from my own work, but before that, let me just make a couple of comments. So to make such this kind of a publication, we have to look at the big picture. So we have to look at kind of some of the overarching science questions, and if our research is not a part of an overarching science question, it does not contribute solving to a big problem, big research science question. So as a result, it doesn't make, suppose we make some independent individual publication, good publication, but at the same time, they are not connected to each other and it's not building up to solving a bigger problem, then they don't make a big impact. Sometimes one paper itself can make a big impact, but many times it doesn't. Just one paper cannot make a big impact. But if you work on different components of a big overarching science question, and if you see that big picture, then by working on the independent component questions, we can actually make a very big impact at the end of the day. So you will make a big breakthrough in terms of solving a big science question. So another thing that is required to have this kind of a big impact making publication is a collaborative research. Today, I think most of the work is the more complex. Problems are more complex, and we need various different experts to contribute to that solving that problem. So you cannot individually, we cannot do that. That is why the most impact making publications today are multi-authored papers, and that many times it is 100 authors and so on. So therefore, actually, I take a policy that even for my PhD students, sometimes if I don't know some part of this, sort of expert, I collaborate with somebody, and then in the publications that those there will be it will be work of the PhD student, but the publication will get the credit for the other collaborators as well. So it's a win-win situation. So we need to open up, but somehow we tend to be rather conservative in looking at these, and that is something that we need to change. I think that is how we can make. So this is one of our work that I can consider a disruptive publication, which is now cited more than 5,600 times. Now, how did it happen? This because this was something. It's also more of a serendipitous discovery that we were looking for something and we found something else. And then when we found that something else, we realized that it has big potential. So then we worked on it to connect it to a bigger problem. And what is that bigger problem? The bigger problem is that until that time, the Indian Ocean was considered as a kind of passive to Pacific Ocean, where whatever happens in the Pacific Ocean, it affects the Indian Ocean through atmospheric teleconnections, and then that Indian Ocean doesn't have an active ocean-atmosphere interaction. While we knew that in Pacific there is an active ocean-atmosphere interaction which produces the climate variability, people thought that there is no active ocean-atmosphere interaction in the Indian Ocean that affects the climate in this region. And we saw for the first time that is not true, that there is active ocean atmosphere interaction. So and that affects the climate of this region in a significant way. So once that was established, the whole scenario, because it has then the consequence of many other consequences. It affects the regional climate. It can also, this coupled ocean atmosphere interaction can also affect the global climate in various ways. So all that opened up the field. So as a result, many people started working. Earlier, there was not enough interest in the Indian Ocean because there was not much happening. So we thought, because this opened up the possibility that a lot more can also happen in this Indian Ocean, and how they happen and what is their implication. So all these started opening up, and that is what made this paper quite citable. So that is what we need to do, sort of whenever we. But for any of these high impact making publications, must stand the test, this 3R test. It must be robust. You have to test its robustness, rigorousness, and reproducibility. I think these 3R test is very important for any good publication. And the reproducibility is very important in experimental science also. And I know even in our science there is an important. But so we also must, sort of see that it should not be, many times we are biased. Many times we have to have an open mind. Science is always is not never sort of it is open-ended in some sense that when we learn new things, we have to change our old ideas. New evidence changes old concepts. So we have to, many times we tend to think that whatever we are thinking is the last word, but that we should have self-criticism, so that we should be your own devil's advocate, and you should think, always ask the question, could it have happened in another way? So ask for an alternative hypothesis, think about an alternative hypothesis. Test that your result is robust against any alternative hypothesis. And then definitely work will stand test of time, and that will make an impact. So in the reproducibility is a very important point. And I think there's a lot of debate. Recently, there has been a big news around in the whole community. The many papers are getting retracted from big journals like Published Nature and others. The recent work of Rangadayas of this Rochester University on room temperature, relatively low pressure superconductivity. This was big news, and it was published in Nature. But then there are doubts about the results, data, and all that. So reproducibility was a problem. So Nature retracted it. So reproducibility that's the big embarrassment, right? And that is sometimes there are big results. Some are come into question because of data problem, data issues. Sometimes data is manipulated. Sometimes data is not properly calibrated or whatever. Many experimental science, there are a lot of other issues. So reproducibility is a very important research, wherever it is our data science or any other science. So how does the citation really relate to this impact-making publication? So let me just give you a quick rundown on. So what are the most cited papers? So the top 100 cited papers, if you look at, the most cited publication was cited more than 3 lakh times, and the top 3 papers were cited more than 100,000 times. But then it decreases rapidly. Number of papers, and the top 100, out of top 100, top 10 paper, 10th ranked paper is cited about 40,000 times. But 100 ranked paper cited is only about 10,000 times. So it rapidly decreases. Therefore, so the top 1% cited paper, when you say their citations are not very big, their citations are only about 50. So that is not a great. So this distribution is very funny. So there, all of them are not making top 1%. All of the papers are not making a big impact. So what is that citation that we need? So if you look at the top 100 ranked scientists, it is most of them, actually a large fraction of them got Nobel Prize, and many others who did not get Nobel Prize, they got equivalent other prizes. So in fact, the top citations are important for impact making. So, but roughly, if you say if the number of citations exceeds 1,000, for example, I think that is one measure that can be considered as a high impact making publication. For example, let me show you a few examples of the top 3 cited publications were in the biological lab techniques, but that is changing now. I think more and more physics and other scientists are also getting into the top 100 scientists. This is top 100 is changing a little bit. and that that demography is also changing in some sense. In my own field, the citations are not very large because the community is very small. Our climate community is not very large. But that is changing because of the climate change. Because the climate change has become a overarching problem across disciplines. It impacts on various things. As a result, IPCC publications are cited very heavily. Most of them are cited more than 1,000 times. But in addition to that, even our science has become more and more recognized, and as a result of that, more citations are coming in the core area of. So at least I know about two publications in our field which have crossed about 30,000 citations. So one of the paper is this paper called by Eugenia Kalni, who was actually a postdoc with me together at NASA at the time. And she is a very great scientist. But see, this work was very simple, interesting. It is a data set that was atmospheric three-dimensional data set was created using observations and the model, and this is called reanalysis. This produced a consistent three-dimensional high-resolution data set across the throughout the globe over a period of more than 50 years, and that gave us a background, sort of a platform to study very climate and climate variability and climate processes in a very consistent way. And that really made a big difference because the data was the good data about studying these climate variability and processes were missing in our field. So that made a big difference, and that is cited for like 34,000 times today. And the other thing that I know is about Professor Ed Lawrence, who is a professor at MIT. He is what we call the father of chaos theory. So he published this paper in 1963, Deterministic Non-Periodic Law, which is now cited more than 27 times because this chaos is now universal. We know it was discovered in a kind of serendipitously. He was solving a very simple 3 ordinary differential equations in a computer in those days. Non-linear ordinary differential equations. So, and then he was looking at the history of this evolution. That represented some, the Bernard convection, which has similarity in the atmospheric dynamics. And so he integrated them for a long time, and then he went back for some coffee or tea, then came back, and he started this he started from integrating the equations again from some past points, and then when he started those integrations from different initial conditions from the past already integrated points, that and then the evolution, he found out that the evolution was very different, and that really got him stuck with this. So what happened is that because at that point when he picked up the initial condition from the printouts, they were truncated to about 6 decimal places. So the errors due to the truncation caused the trajectory of this evolution is changed. So it means that this whole system equations or the system that is represented by the equations are very sensitive to initial conditions. And then he, of course, that was the big source of the nature of these chaotic systems. And it turned out that that is the basis for predictability limit in the atmospheric system and the weather and climate. And so, and it seems to have has applications in across many different fields, and that is why this is a very highly cited paper. So So that is the kind of thing that we're looking for. For example, now we talk about the 2021 Nobel Prize in our field, and this Suki Manabe and Klaus Hasselmann and Parisi, Giorgio Parisi, they got Nobel Prize in recognition of universality of complexity across disciplines and making accurate estimate of climate impact of doubling carbon dioxide as early as in 1967. So these people are also highly highly cited. For example, Manabe has 15 papers or more, about 1,000 publications, above 1,000 publications. Parisi has more than 1 lakh publications. They have one paper, 10,000, more than 10,000 publications, and so on. So these impact-making publication, public citations are high citation papers do make impact. So okay, so where do you go from? Where do we need to go? So again, talking about high impact making publications, we are happy for small achievements, but complacent, and they do not think big. I think this is our problem. So we need to have a long-term vision, because we should think where the field is going, and we should think about what we need to prepare. And that long-term vision actually affects the young scientist in some sense, and because that long-term vision is what helped, for example, today bring this Nobel Prize in Physics in GFDL for Suki Manabe, for example. So I know that this is Manabe, and actually, our field, the weather and climate, accelerated in around with the first weather prediction, numerical weather prediction that was performed in with the first computer available at the time at Princeton University under the leadership of Professor Jules Charney. And soon after that, we started building a climate model. And the GFDL recognized that the climate modeling is going to be the future of this in the field, and so they put together a team, bringing Joe Smagorinsky, who worked with Jules Charney, and to lead the institute, and they brought Manabe from Japan, and Kirk Bryan is an oceanographer, ocean modeler. Manabe was a atmospheric modeler. So that Smagorinsky then motivated them to build the first ocean atmosphere couple model in about 1970, 71. So, and then the rest is history, and that is the work, and that is the vision that triggered a lot of work in the US itself, and then so. And then led the field. But what happened in countries like India, for example, we lacked that vision. And in fact, we lost during that period of time, from about 60s to 80s. We had thought that some of our seniors thought that we don't need models. We need models for weather prediction, or and they will have some errors, and so we can solve this problem with observations. But that was a very short-sighted vision. As a result, we never tried to build the computer infrastructure. We never tried to build the capacity in the climate modeling, and we got sort of the whole country became behind the rest of the world by 30 years, as Professor Soike mentioned. So, and that affects all of us, because we could not do the kind of cutting edge work that we could have done if that vision was there. And the country has to have that vision. The leadership has to have that vision, and so that in the leadership in the individual fields. And so other thing that we have to also do is to keeping pace with the development. These fields are changing rapidly, and we need to learn what is happening, what is new that is coming, and learn new techniques, and so on. So many times, let me talk very briefly. I think I'll not spend too much time now. I think so. Some of these discoveries are serendipitous, as I mentioned, but most of the discoveries are not serendipitous. It requires hard work. Most of the big discoveries required hard work, and hard work of identifying a gap area, making hypotheses, solving component problems, and maybe publish a synthesis paper, and finally combining and synthesizing all these into a big picture. So that is what brings out a big impact. And in fact, that continuous hard work is very important in terms of publication, and the continuous publication is very important in terms of impact-making publication. So this is a study which showed that survey looked at 1.5 million scientists and their publications, and these publications, they found that out of these, only 150,000 scientists, 1% of them published without missing a year. And these people constituted 47% of all the publications. And there's something 87% or 85% of the high citation papers. So the continuous work is important. These big ideas are not going to come if you just stop working. And then, so if you keep on working, amongst this, some big ideas will come. And that is what is important. So I think that is, so let me stop, because I have not talked about the methodology, but I think in this methodology is important part, but there is a lot of different methodologies in different fields. But I think the signal processing is something that is important. To find a signal or is very important in big discoveries, whether it is in climate or it is even in sort of finding the gravitational waves. It's a lot of signal processing. The signal is buried in noise. In all the time, signal is buried in natural system, has a lot of noise, and that noise is our complexity. So to bring that signal out of that is very important. And if you don't do that correctly, then we lose the signal. So that signal processing, and the signal processing is going to be revolutionized with the artificial intelligence, because that can do nonlinear signal processing. And so I think we need to embrace on artificial intelligence in almost all our fields. In conclusion, what I have talked about is to improve high impact publication through increasing the number of high quality PhDs and postdocs by improving the research culture, research focus and environment, and academic environment excellence. But however, in the state and private universities, it is not going to happen unless the faculty recruitment is reformed. And the science and technology infrastructure funding is significantly increased, at least to the level of the central universities. And so, in my opinion, I see that in my state now, the state universities are opened up left, right, and center. Every college is converted into university, and this is a disaster, I think. So this should stop, because unless a private university fulfill some of these conditions and have these reforms and autonomy, then I think it should not allow this institution to form. But there is other issues, like the number of we want to increase number of high quality PhDs in the postdocs in the country, and we need that for innovation. But do we have enough jobs for them? That is what is happening. The good quality PhDs should expect good jobs, and that kind of good jobs, enough jobs are not there in the country today. That is why we are not able to really expand this country. So we need to improve job infrastructure in the country. Government institutions and the academic institutions, job opportunity is declining. It is not increasing. So, and the private organizations, unlike USA, have very limited postdoc PhD. They don't take too many PhDs. How many PhDs the private organizations take in India? Whereas in USA, you see, there's plenty of jobs in the private. With the training in the academic institution, these people get jobs in the private. They can go and do things, research over there, R&D over there. But in our country, I don't see enough R&D going on in the private, and enough people being taken, and that is what I think they have to change. For that to happen, academic institution, in addition to doing basic research, maybe one way is possible way which people are talking about is to have to sort of in the institution, academic institution, have projects in collaborative mode with the private sector organizations to do research, a basic research which they might need, or that sector needs. So I think that is what we need to do, and with that, I think I'll stop. I think I have taken more than time allotted to me. I thought I'll finish in less than an hour, but thank you very much, and I'd be happy to answer any questions. Dhruva, are we too late for questions?
We can have some questions and comments and discussion.
Yeah, sure. Yeah.
Hello, sir. This is Radhakrishnan from Madras University.
Hi.
Sir, I have a question. And I'm just asking because of your experience in means like in a higher level. So, sir, see, how can we handle the discrimination against the marginal communities? For example, see, academic score as well as various other things in Madras University, if you look at, see, it is most of the time, see, the toppers and good means those who are genuinely working are SC people. But they are selectively targeting people, those who are only concentrating on academic and not political. They'll have been tortured like anything. All sorts of things. So means again at a higher level, okay, how can we, for example, okay, even my one of my friend, okay, who even had a nature paper. Our university means okay, they don't give money for that, but still he had a nature paper, and he was not. See, now they implemented the rotation after a long time because of various other problems. These HODs were because okay, once they become HOD, they will be HOD for years, and they because of that, okay, VC will combine with all HODs, and they will do all these HODs will do all nonsense, especially against the marginal communities. This is a typical thing. But now even that fellow who had a nature paper, his academic is very good, and he was not even given HODship. But okay, so the VC has selectively given it for certain people. So these kind of things, okay, how to overcome, because
that that is a very you are raising an important question, and I agree with you completely, because I think there is discrimination in some form or the other in different institutions at different levels, but even we have faced somewhere here and there. But this is an issue that I don't think.
For example, they are giving best academic researchers every year. Every time, this SC people will be there. Most of the time, more number they will be there. And even one faculty who has produced a lot of PhD, and she is being getting the best award for the past 5 years. She was not even given professorship. So these kind of things, okay, how we cannot, okay, they might have gone to court and things say that, see, there are rules. But okay, how, I don't know. I mean, okay, as an experienced person from a higher point of view,
I have no. This is something that this is an individual issue. No, it is like there are individuals who have certain biases, but in my effort has been that we always encourage marginal community, and that has been my principle, and I have always tried to do that in wherever I was possible. But these are the issues that are bigger. This is a question of mindset that some people have, and you cannot. I cannot change that. It has to come from the in society, come from our larger education system that creates this awareness and make them change their mindset. So it's a very big issue. It is not a simple issue, but that kind of individualistic sort of individual based biases are there in the system. It's all there in many of our as I mentioned, our fellowship and award committees and other things. Everywhere there are biases based on persons, and those persons may be not necessarily on this community, particular community, but there are biases of prejudice of selecting this person against that person. So these are pitfalls of the systems that it's not possible to correct overnight. We have to try to keep a bigger picture, bigger picture, and try
legally
to
also, sir. Now I found that someone they have to cope up with the system and go. Because legally also it will take years to get your result. Those who are academic, those who are purely in academic, they are the one who is suffering. So your what you said is completely correct. That's what I found. But I was just asking whether the new NEP.
I can't give a new solution right now. But this solution will come only slowly. We have to keep working on it, on the mindset, changing the mindset of some of the people.
Yes, sir. Yes, sir. Non-academic people working in academic, that is the problem.
Dr. Gaurav has his hands up, has a hand up. Dr. Gaurav, would you like to ask your question?
Yeah, thank you, sir. So, Professor Goswami, thank you for this wonderful talk. I mean,
thank you.
Showed us how one should plan research and other useful advice. The first thing that you told us that you were a plasma physicist.
Right,
I also did my PhD in plasma physics. And then
I was a plasma physicist.
Yeah, and then you moved to meteorology.
Right.
So, if you could share journey in a brief. And second thing is that you talked about citations and which are measure of impact of research. And it was new to me to learn that these are counted in deciding the Nobel Prize or sending the nomination for Nobel Prize. I mean, where else we can utilize them in the academia? In terms, I don't see that these are the criteria right now in terms of promotions or other.
Okay. So let me talk about the first question. So first question is that, of course, I wanted to do plasma physics, and I was excited about solving the thermonuclear fusion energy problem, and I was very excited. But by the time we finished the PhD, the job opportunities in the plasma physics was very poor in this country at that time. But an opportunity in working in the meteorology came by. Again, that is a vision of the PRL people, PRL director, that they wanted to start a climate center, climate research center, and they invited us to me and a couple of other fresh PhDs to start working on it if we were interested. But we had no idea about what this field is. But there was a person in the so there was one professor, Professor P.R. Pisarati. He was a very excellent teacher and a great scientist. So he was a PRL, and he gave us a course on these on the problems of the meteorology and how the dynamics of climate, weather dynamics and climate dynamics. So that actually opened up our sort of vision that this here is a field which is upcoming, and if we can make the improvement of forecast, it is going to have a very significant and an immediate effect in the communities. And that actually made our decision easier. That because there was a great teacher who exposed us to what is going on, what is the field, and then the possibility of its application to society in a shorter time frame is what actually excited us. And my transition to it was not very difficult because the fluid mechanics is what is a common factor in both the fields. So that is why it was relatively easy. But the phenomenology was an important part, because without knowing the phenomenology, what is happening in this field, in this atmosphere and the ocean, what are the processes, those took time to understand and get into this. So therefore, actually, it took another 5 years before we could really get into the field. So in a way, the transition is tough, but I was fortunate that I had help. So coming back to your question of citation, and citation is counted in many places. That's in many fields, but that is not the only factor. See, we cannot decide a promotion or something or a award only based on one factor. So finally, the citation is a gross measure, where if it is above something, then it really must be impact making. But if it is below between certain citations, it is very hard to say whether one is better than the other, and that requires actually a committee of experts or the peers in the field to decide whether a particular paper is more or the contribution that this paper this person has published has a bigger potential for bigger impact than the other with similar kind of citation. So therefore, citation has to be taken in conjunction with other factors, like impact factor. Publication is one, citation is another, but on the top of that, we need and on Nobel Prize is also not giving only based on citation. Sometimes there is less citation. Scientists also have got a Nobel Prize because they felt that there's the concept that they have developed or something that triggered has the much higher potential for applications in the future or change the field and so on. So, but the citation may not have been that much, but that can also happen. So that is decided by a peers, a committee or a group of peers or the experts in the field that say that this is what this has the potential or this is what it has made. So that may or may not have got the same amount of citations. So there is a combination of three things are required. But today, I think sometimes we tend to do only with these numbers. The numbers cannot give us a very accurate figure all the time. And at some levels, there is a certain amount of uncertainty based on the numbers alone. That has to be finally. So therefore, we have to come back to these committees. So these committees of experts. So these committees of experts can have to. But in that committee of experts, we need honest and so we have to select those committees as competent and unbiased people. That is what we have to do. That is the only thing that we can. So if those
I have just to add a few things. See, Gudda's question and your answer was apt because nowadays this citation is very, very important, and in which journal you prepare your paper and it's got published. Okay, that will be counted in the career advancement scheme in university. Yes, they have different schemes for it, and you have marks. But I want to make a comment on it. Okay, since you are from physics, I am also from physics. So earlier it was very difficult to publish a paper in physical review. Yeah. So it means that at that time it was considered to be around 2000 time. At that time it was considered to be very good journals, and publishing it in it is a very quality kind of paper. For example, say purely in pure theoretical physics, or let's say astrophysics or specific things. But let's say computational material science, they are publishing papers, and their impact factor is very high, but the quality of the work is very low compared to the physical review. Right now, physical review A has impact factor 2. But you see, okay, you might know, okay, it's so difficult to get published in physical review.
I agree.
So
I
your
agree.
point is exact. Means, okay, it's on the kind of work and kind of, okay,
Exactly.
exactly.
And the impact factor depends in different fields. Different fields, it is very different. So you have to normalize it from different fields. So the citations will also change. I have mentioned that briefly here, but there are many journals which have a low impact factor, but very good journals. They are very high impact making journals, but their impact factor is low. Relatively due to various things, because number of people may be low in that field and so on and so forth. But yes, for example, Journal of Fluid Mechanics, for example, has a very low impact, not very high impact factor, something 2 or 3 or less.
Magnetohydrodynamics kind of thing.
Right. But this is a very good journal. So I would give, so that is what the expert will have to decide, that I will give high mark for that. So that is the kind of thing that you need to do. So the numbers are a sort of rough reference point. They are not the final evaluation. So evaluation needs, as I said, the people, experts from the communities who should judge that those impact factor journals are good. And today, some of the impact factor journals, the impact factors are manipulated by the publishers themselves. So there are issues like that. But as I said, at some level, 100, 200 citations, then you can manipulate. But if more than 500 citations, you cannot manipulate. So that is the kind of thing that, sort of, there are, all these things are something we have to take in together to evaluate a faculty. So, so the faculty evaluation cannot be done simply by, but my point was for making good publication, to aiming for good publication, you have to follow some sort of strategy, and that strategy is high citation, high impact factor is a strategy to follow, and that culture, if you develop, then that, because some of these good journals, as I said, even in Nature, for example, as I said, only 5% are very much cited, but the rest of them are not cited that much. But they have developed a culture of review which requires you to work hard to show the robustness and the reproducibility and the rigorousness of the work. So that makes, if you satisfy that, it already makes your quality of the publication higher. So that is why, even if citation is low, then there will be certain amount of weightage to that. So I feel that it's not a very, single number. We cannot judge everything, but in a philosophical sense, only I have suggested citation as a parameter to follow.
Sir, I'd like to share one my experience. I'm Jyotirmoy Pramanik from Kharagpur College, and I'm IQC coordinator since 2018. So I have seen that, suppose in CAS, Career Advancement Scheme, so for publications in category 3, we have to, teachers have to get some score, or 75 score like that. And they have to publish their work in UGC Care List journal. And I have seen every month UGC discontinued some journals, every month or every 2-3 months. I mean, suppose in June month, in June 2019, someone published one paper in some journal. From July, it may be discontinued. So means UGC Care full form is Consortium for Academic and Research Ethics. So then, if one journal is ethically UGC Care listed, then it should not be discontinued within a month. But it means, I think it should once a year it should be standardized, not every month. So this is very difficult. Means to finalize this score.
Yeah, I think I agree. These are issues that
all time you have to check that care list is listed or not. Like
Yeah,
that.
actually, Dr. Pramanik, if I were to just comment on that,
yeah, yeah.
when
Dhruva.
UGC started listing the journals,
Mm.
there was a whole, a very significant fraction of just predatory journals.
Exactly. So that they made a
And
big,
when this was pointed out, these were removed. And I mean, opportunities that I've had for discussing this issue is that there is still probably many journals which are substandard. And I think once I agree that it should not keep coming in and out, but I think great care should be taken to make sure that it is of the appropriate standard before it gets listed at all.
exactly.
And the very procedures that the UGC has adopted, I think it's very easy for predatory journals to get into the system. I remember when the first list was made, the way it was done was letters
It was
on the
disaster. Disaster.
names of journals.
Mm.
And I also had various people coming to me that, could you please recommend my journal? The problem is I did not do it because, I didn't think they were up to the mark. But on the other hand, I can very well see situations where vice chancellors would recommend and it would come into the situation, sometimes just yielding to pressures, sometimes, I don't know, maybe financial gains, I have no idea. But the thing is that unless you put the academic standards very high, I think all kinds of journals will keep coming into the UGC care list. So
Correct.
I think when Professor Goswami mentioned about aim for, good publications, probably you just look at not the impact factor of the journal web page, but probably the journal citation reports or reports, which actually are far more reliable than the manipulated values which you see in the web pages of the journals.
Right. Mm. Right.
Just one or two more questions at the most. One is by Dr. Sukesh, which says, with the government opening up education sector and foreign universities getting to set up branches in India, will the scenario of research in India change?
I suppose it can change, but unless we address the basic issues of exciting the students, again, it is simply because of giving a degree, because many of the students will be interested in joining such courses because this is the degree is joint degree with some foreign institution. But foreign institution, not all foreign institutions are of top class. So we have to recognize that. So we have to have, we have to collaborate only with those institutions which can give where the academic environment is also sort of getting academic environment for doing excellence. So if that kind of institution, if you collaborate, then the students, when they visit them, there will be some sort of sort of exposure, which exposure, as I said, is exposure will excite them. So I think that is what we need. So if those collaboration are correct, if you don't have the right kind of cutting edge research labs in your this thing, and the students can go and spend a few months, 3 months or 6 months in a research lab which is doing great work, and they get associated with them, I think these students will get excited, and that can really help us. So well, it's again a question of how you do it and where you collaborate, which institutions you connect to. If you just simply connect for the sake of sort of giving a degree, and that institution has no real standing or environment to really excite the students, I don't think it will make a big difference. So it's a question of sort of. I think the idea is good. The question is that we need this exposure of the students to this exciting environment, and that where they get excited about the new science that is, and then start thinking about a burning desire to do something like that. And that is what excites the student. So I think if this kind of a joint degree by different degrees helps the students to do that, I think that is good. But it has to do that.
Actually, the challenge is, I mean, today, if you look at the large scenario, I mean, the government is, aiming for a 50% GER. but very little investment in public funded institutions.
Exactly.
So the private sector is going to play an increasing role. And the private sector, you can see the output today from the existing private sector institutions.
Right. And
that leaves a lot to be desired, actually, isn't it?
Absolutely, and I am very worried because and then it might be then the whole science innovation might not happen, because there is somebody in the private sector, some agenda will come up and say that only this is what we want to do, research, and they will put some money in, and that research might have some commercial implication, but may not have really generate more science and new innovations. So I think this is a big disaster going to happen unless the private sector itself increases their own R&D infrastructure in a big way, because I don't see their own investment in the R&D is very poor, and that is why they don't need too many PhDs to come and help them. So unless they do that and invest in big way in their own R&D infrastructure, this getting some money, and the government is not going to get this 37% or whatever, 37,000 crores from R&D. So this is, I think this is, in my opinion, this is a disaster. I think already we are only 0.6% of GDP, and then you remove everything else, and thinking that, and what is the history of private sector helping into the research? In my opinion, zero. So I think this is a disaster going to happen.
And actually, with the right culture, we can see that, even in India, within India, we are capable of building good institutions, but probably
we are. All we need is a little more help from the government. That is what we need. Little more money, little more funding, and autonomy. Now both are being restrained. So then I think we have a serious problem.
And as Professor Goswami's chart in the beginning showed, that the bulk of our institutions are actually state universities. And if you look at the status of it, both in funding and terms of and also the teaching workloads of the faculty over there, I mean, it's incredible actually, how much time can they spend on actually doing research, which will, fetch citations and top-class journals.
Yes.
But I think the first step for an individual is still to, what Professor Goswami outlined, is just aim to publish in the best journals. And that itself, if it's a strong motivating factor, will be a good first step, And I still remember anecdotal accounts. For example, there was an associate of Ayuka from Kashmir who said he used to publish in sort of second-rate, third-rate journals, and just by coming to the Inter-University Center of Astronomy and Astrophysics, interacting with people over here, he has done this publishing in monthly notices.
Yes.
Big step,
That is exactly what I say. And the potential is there. I think potential in this country is unlimited. What we are not giving them the incentive and the opportunity. And we have to expose them and give them the opportunity and the incentive. So I think we can do wonders. So, but the way the funding and this hiring of the institutions is going on, I don't see a great future.
Actually, building up diverse faculty with the best expertise possible. And the thing is that you need the vision in the leadership of the institution to actually do that.
Absolutely.
Because even with experts sitting over there, experts also have their own vested interests.
Yes.
The leadership of institutions have to make sure that doesn't happen, and the vision of the institution to get the best faculty is actually met.
Correct.
And the way you constitute committees, you have to keep that in mind. Otherwise, everything can be fiddled, actually.
Absolutely, I know.
Okay, it's been a very exciting evening. I
Thank
Professor, Mr. Patnaik for a nice summary, and then this is followed by Professor Goswami's talk, which also there's been a lot of discussion, which is a wonderful evening, and end by thanking both Professor Patnaik and Professor Goswami this evening for a very, very interesting evening. Thank you very much. And thank you all of you for attending.
Thank you, Dhruva.